Example 3. For tax reasons, I need to create a rectangular vegetable patch with an area of exactly 242 square feet. The fencing for the east and west side costs $4 per foot, and the fencing for the north and south side costs only $2 per foot. Talk about that in a minute. What are the dimensions of the vegetable patch with the least expensive fence? Use the second derivative test to confirm your answer yields a minimum cost. I talk in class about why sometimes we're restricted to the size of something. Maybe there's government regulations. The other piece is notice the east and west, which is the, left and right facing walls, are more expensive than the north and south walls, in our case the top and bottom. And that would be because the sun rises in the east and sets in the west, so there's a lot more direct sunlight coming at those angles, and so you might want to buy a little bit higher quality fencing to protect your vegetables. Every time we have a problem of this nature, we need to find both a given or restriction equation or equations, and what are we trying to maximize or minimize. Whichever one is easier for you to find first, that's great. Some people say, hey, I know I'm stuck with the prices of the fencing. Other people say, hey, I know I'm looking for the cheapest I can spend. I'll go ahead and start with the fact that I'm told that the area has to be exactly 242, and then we've got some other restrictions within that. But focusing on the area being 242, we usually use A for area, but since we have the dimensions x and y given for us instead of length and width, let's use x times y equals 242. I have now found my given equation. There's only one for this problem. Next, I'm focused on the phrase least expensive fence. Now, it also does say minimum cost, so you kind of have that hint down there, but that's not always going to be in your question. So since expensive is also referring to cost and least means we're minimizing, we also know minimum cost from the other phrase. Okay, we need to look at the fencing first. The least expensive fence, how much fencing do we have? So if you think about it, we have these two X's that run across the top and the bottom, and we have these two Y's that run across the left and right side, east and west. So whatever Y is, if it's 10 feet, we have 10 feet and 10 feet. 2 times 10 feet will give us 20, exact, etc. Okay, so I figured out the fencing, but now I need to look at the cost. So it says east and west, $4. So let me put that on the left and the right. North and south is $2. So let me put that on top and bottom. You really just needed to maybe write it once next to the variable it goes with. But as I go to write my 2x phrase, I have $2 times the 2x piece, and I have $4 times the 2y piece. So in the end, my cost is 4x plus 8y. I just multiplied the values and dropped the number signs. So now I have a function that in this case I need to minimize. Just writing that there as a reminder. Now my goal would be to take a derivative of this function and find the critical values, but as you notice, since we have two variables and we don't know how to take a two-variable derivative yet, then what we're going to have to do is solve the given equation for one variable. That's 1-v. It doesn't look so great. So I'm going to take my given equation of xy equals 242 and go ahead and solve for x. So dividing both sides by y, I've got x equal to 242 over y. Now I can plug this into the function I'm trying to minimize. So I have my cost function, which is c times 4, but where x goes, let's go ahead and substitute in 242 over y, and then I can just finish off with my plus 8y. Notice I have the same single variable in my function now. Let's clean up this by multiplying the 4 with the 242. Because I'm going to take a derivative in a minute, instead of writing this over y, let's just write y to the negative 1. So now I can go ahead and take the derivative of that equation. 968 times negative 1, and then of course subtracting 1 from the exponent gives me y to the negative 2 plus 8. And this is the equation that I need to set equal to 0 to find critical numbers. Sorry about that. Okay, so what most people will do is add this to the right side. So then I'll start off with 8 equals a positive 968 over y squared. As I've stated, I find most students tend to cross multiply because they see both sides as a fraction, where they can multiply 968 with 1 to get 968, and 8 with y squared to get 8y squared. And this equation is easier to solve because you're going to divide both sides by 8, take the square root of both sides, and even though it should be plus or minus, we're talking fence dimension, so we can just take the positive square root to get 11. We now know that our rectangular garden patch or vegetable patch is going to be 11 feet wide on the east and west side. But I'm still supposed to use the second derivative test to verify, or in this case confirm, that it is a minimum for my cost. So I need to take the second derivative of c. Looking back at my first derivative of c, I need to multiply negative 968 with negative 2. So we'll get positive 1936, and subtracting 1 from the y squared gave us y to the negative 3. And remember, the plus 8 just went to 0. So I need to test my critical value, in this case 11, into this derivative. Get out my calculator, and what I care about is I got a positive value, which means I'm in a concave up region, and during that section all critical values are minimums, and that's what I'm looking for, the least expensive fencing. So I found the minimum cost, or what values give me the minimum cost. So now I need to find the other values because I only know that I have an 11 feet on one side, but I need to find out what is the dimensions on the other side, the x or north and south dimensions. So where y is, we'll plug in the 11 that we confirm to be our minimizing value, is that a word? And we get 22. So now we can turn around and answer the dimensions of the east and west fencing and the north and south fencing, and they just want one dimension. So if you think about it, east and west was the $4 fencing, which is where y was, and we found that y is 11. So this is the answer that would be 11. And what are the dimensions? It just says least expensive cost, but right now I'm finding the dimensions, how much fencing I have. And so since it was $4 per feet or $2 per foot, my answer is in feet. And same thing goes, the north and south was the $2 piece, where we were using that in place of x, or not in place of, but to find x, and we found our x value to be 22, also feet. So I have my answer.